Hello viewers, welcome to my channel. In this episode, we want to take the tutorial on binomial expression or binomial series, binomial expansion. All right. Now, when we talk of binomial expressions, we are only referring to two terms that are connected by either plus or minus. So if I have a term, let's say P plus Q. This is a binomial expression. We could also have P minus Q exponent of 2. This is also binomial. They are just two terms that are connected by a plus or minus. When I mean two terms, we can still have 2p minus 3q or exponent n, where in this case n stands for our natural number or whole numbers starting from 0 increasing. So if we are going to consider a and x as the integers we want to use as binomial terms. So if I have a plus x with the exponent of n, where in this case the a, the x, and the n are integers that we are going to use to represent any other terms, p, q, any other terms that we might see henceforth. Now, when we have this, where our n is a whole number starting from 0, 1 in that order. So you can see that if I write a plus x exponent of n equals 0, we are aware that any number that reaches power 0 give us what? 1. So this will definitely give us 1. Let's just say we have our a plus x, where n is now 1. We are aware that any number that raised to the power 1 remain the same. So this will give us our a plus x back. Let's go further and say that we have our a plus x exponent of 2. We are aware that this simply means a number raised to the power 2 multiply itself 2 times. So this could also be written as our a plus x times a plus x. And in this case, we can use the FOIL method to arrive as a times a give us a squared. We know there will be a times x, that will be ax, x times a, that will be 2 of them. So we have 2ax, then x times x will give us x squared. So this is the expansion if we have a plus x squared. So now let's take a step further by having our a plus x to the power 3. You see we are increasing the powers. So this will give rise to, a squared times a give us a to the power 3. So the whole of this is going to be a plus x squared times a plus x. That gives us the power of 3. Then in this case, we are only going to use the a plus x to multiply already known expansion that we have. So a times a will give us a to the power 3. Then when a multiply this, it gives us 2a squared x. 2a squared x. Then when the a multiply this, we get our a squared, ax squared. Then this is also going to multiply here to give us our a squared x. Don't forget this is always squared, right? Then this is also going to multiply, increasing the power of x to become 2a squared, as you can see in that case. Then x times x squared will give us x to the power 3. I am doing it this way because I am seeing a common factor, a squared x, a squared x. One of them, 2 of them. That gives us 3a squared x, ax squared, ax squared. One of them, 3 of them, 2 of them. That gives us the 3ax squared. Then finally we have our x to the power 3. If you take your time and multiply all of them, you arrive at this. All right. Then let's take another, I think, another step. In this case, we have 4, which also mean a plus x exponent 3 times a plus what? So now let's see how we are going to multiply that. Don't forget this a plus x is doing the multiplication throughout. So let's expand it in that step. So a times a to the power 3 will give us a to the power 4. Then a times a to the power 2 will become a to the power 3. Then the x will come. So 3a to the power 3x. The a is coming here, increasing the power. So 3a squared x squared. When the a here, it will only introduce itself a to the power 3. We move in terms of x. Going here, give us a to the power 3x. A to the power 3x. So we are going to have a to the power 3x. Then the x is going here to multiply. It will increase this power to become power 2. So a to the power 2, x to the power 2 will be here. Then when the x go here, it will increase this to become 3. That will be a power 3, x to the power 3. Do we have it here? A to the power 1. So we have a, it will be 3, right? 3a x to the power 2 times this will become to the power 3. This will also be 3. Then the x is not going to multiply this to give us x to the power 4. Alright, I'm trying to group them together before I write. So we have a to the power 4 as the only one, a to the power 3x. So we have 4 of them. This is 1, this is 3, so we have 4. A to the power 2, x to the power 2, we have 3 of them plus 3 of them. That gives us 6a squared x squared. Then we have a to the power 1, x to the power 3. 1 and 3, making 4. Then the last one will be our x to the power 4. Alright. Now, you see how tedious it is. If I were to move another step, which will be the fifth one, you can see that we are going to be suffering in order to expand all of them. So we can generalize it in a way that multiplication in the expanding form will be limited. So we are going to use what we call the Pascal triangle. How do we get the Pascal triangle? We are going to be dealing with the coefficient. Okay, you'll be dealing with the coefficient of all the terms. And you can see the first one has given us only 1. Then the coefficient here is going to be 1. So we have 1, 1. 1 here, 1 here. Then when we come here, we have 1 coefficient. We have 2. Then we still have 1. Do you see that? 1 coefficient, 2 coefficient, 1. When we come here, we have 1 coefficient, we have 3 coefficient, another 3 coefficient, and 1. I believe you are seeing what I'm seeing. Here, I have 1 coefficient, so 1. I have 4. I have 6. I have 4. And I have 1. So this is giving us a triangle or a pattern, as you can see. 1, 1, 1, 1, 1. 1, 1, 1, 1. 1, 2, 3, 4. You can see that? Then you have 1, 3, 6. 1, 4. There's a pattern. 1, 2, 3, 4. In that order. So we can see that if I'm able to see the pattern in this, I should be able to generate the next coefficient of my binomial expression with the power 5. Let's see how we can do that. If you look at this, 1, 1, 1. 1 plus 1 give us 2. The leading coefficient is always 1 and the last is 1. You can see they are all 1. The last is all 1. So the extreme is 1. So if I pick the 1, 1 plus 1, 2. So therefore the last will be 1 If I'm here, it will be first will be 1, which is the leading coefficient. So I'm going to have 1 plus 2, 3. 2 plus 1, 3. The extreme, 1. Here, the extreme will be 1. 1 plus 3, 4. 3 plus 3, 6. 3 plus 4 plus 1, 4. The extreme. You can tell that the next one will be 1. 1 plus 4, 5. 4 plus 6, 10. The 6 plus 4, 10. 4 plus 1, 5. And the last one will be 1. So you can see. So the next one, you can be able to generate all the coefficients. Now, that's one aspect. So we use the Pascal triangle. So if I know this, I'll only have to bring in the a and x into it. How do I get the powers? We can see that the powers of x keep on decreasing. If you look at the powers of x, the powers of a keep on decreasing, whilst the powers of x is increasing. If you check, even though I've cleaned the other ones, you see that a is 4, 3, 2, 1, 0. X is 0 here, 1 here, 2 here, 3 here, 4 there. You can see, so we are saying that the coefficient is what we have from the Pascal triangle. The powers of the a and x, the a is what? Decreasing. The powers of a is decreasing. Then the powers of x is what? Increasing. Alright. The next pattern to also see is that at any point, the powers, the sum of the powers is equals to the n. So here is x to the power 0. 0 plus 4 will give us the 4. This is power 1. 1 plus 3, 4. 2 plus 2, 4. 1 plus 3, 4. 0 plus 1, 4. So you can be able to generate the terms of any binomial expressions if you know the Pascal triangle, which is the coefficient. So if I have a plus x exponent of 5, you can tell that here is going to be the first coefficient, going to be for a, and a will be to the power 5. So plus the next coefficient will be 5. The power of a must decrease. So a exponent 4, x exponent 1, 0, 1. 10, this will decrease to a exponent 3. This becomes exponent of what? 2. So that when I add, I get 5. Plus 10, exponent of a, 2, x exponent 3. You add, you get 5. Plus 5, a exponent 1, x exponent 4. If you add the powers, you still get 5. Plus x, which is the last coefficient, 1. X to the power 1, 2, 3, 4, 5. So that's the generalization that we have. So in binomial expansion or expression, we can use the Pascal triangle to deduce the coefficient of each term. Alright. Now another thing is that for the number of terms to have is the n plus 1. 1, 2, 3, 4, 5. 5 terms. The n is 4. 1, 2, 3, 4, 5, 6. 6 terms. The n is 5. So that's how we generate the coefficient. I know the video is a bit long, but you take your time and grab all the points and the principles and properties laid down. This being the first episode, is laying the foundation for the subsequent episodes. Thank you for watching. Don't forget to tag somebody, share with them, encourage them to subscribe to the channel and be part of the family. Bye-bye.